Now let's take a look at the elliptic envelope fitting. Here the main point is that we need to find the outliers within the dataset itself. Let's take a look at the elliptic envelope fitting, which is used to find the outliers within the dataset itself. So if you have outliers in the dataset, so you can actually take them out with the help of elliptic envelope fitting. However, one thing to notice is that if we know the number of outliers in the dataset, so this technique works very well. So, and if the outlier number is not correct, or in case of false positive, we can have we have decreased the outlier ratio as well. So number of errors will be increased. Here we just have a very hypothetical data sets that we have created for our case study by ourselves actually. And what we do over here is that we just plotted it, and you can see the outliers are actually with the black dots, and the green dots are actually for the inliers. So data is very much organized, and when we actually draw the boundaries, so here you can see the Gaussian distribution as well, like this. So on the zero you have most of the data on the main, and then the Gaussian distribution like a bell shape which is drawn over here. Um the point that I'm going to make is that there are four errors, so you can count. This is one inlier which is modeled as outlier, two, and then we have a three, and we have the four. So number of errors are four. For the non-Gaussian distribution, we have another data set that now we have plotted. You can see this is actually data which is scattered in three different locations. So it's a non-Gaussian distribution, and when we actually draw the boundaries over here, and the number of errors in this case are 8 actually. The method, the elliptic envelope fitting, actually produce 8 errors uh, in prediction when it was actually modeling or when it was actually trying to get the outliers from the data. So there are 8 errors in the non-Gaussian distribution. Thank you.